So now we're going to move on to this day 2 of 3.4. And it should also be fairly short. We're only going to basically do one problem, and we're just going to do kind of the same thing over and over like we did in 3.4 day 1. So the same kind of thing, but it's just slightly different. We're going to be working with something called piecewise functions, something new here. So how do you write an equation of a graph with multiple slopes? So now it's not just going to be one line or one equation that we're going through 2 points. It's going to be a little different. We're going to see if we can do it with an actual graph that changes slope. So this is going to be called piecewise. So a piecewise linear function, what is it? It's just a function or graph that is literally described in separate pieces. As an example, if you look at this graph here, if you can tell, every so often it changes the slope. So first you have it coming up, right? And then at some point here, it changes slope. So this is actually like a different equation. And then it does it again, goes up, and then it changes slope again, and then it comes down. So this actual graph here could be described in 1, 2, 3, 4, 5 equations, 5 separate ones. And then the one over here, which is actually what we will be doing, it shows you the equation and how we're going to be writing it. This goes up forever, or not forever. It goes up to this point, then changes slope to here, then changes again. So this one will be described in 3 different equations, which is what we're going to do. So we're going to make a graph, and then we're going to create the equations to find all the different slopes that describe each one for each part of the graph. So let's try for example 1. We're going to graph this situation, and then we'll make the equations. So the boat, we're talking about a boat. The boat is now at a pier. The boat moves away from the pier at a constant rate for 5 minutes until it is 300 meters away. So that's pretty important. 300 meters away. It drops anchor there, and it stays for 10 minutes. Then it goes back to the shore at a constant rate for 7 minutes. I'm going back to the shore at a constant rate for 7 minutes when it arrives. Okay, so our goal is we're going to write the piecewise linear function and put it into equations for each line. But first we have to graph it, and then we'll make the equations. So we're going to graph the situation. So right here we have the time on the x-axis, we have distance on the y-axis, and I just simply labeled it as 2 blocks would be 150. I guess this is in meters, right? It says 300 meters. So these are in meters. So this is 150, and then this here would be 300. And it doesn't line up that perfect, but hopefully you can see that. So everything here is actually going to be 75, right? 75, 150, and then 225 would be the next one. Rewrite that. And then the time down below, it's going to be every 2 blocks will be 5 minutes. So 5, 10, 15, 20, 25, kind of like that. It's a little below it, but that's all right. So let's start with the story. The boat's at the pier. So what we're going to say here is the distance away from the pier is really what this should say, the distance away from the pier, and the time. So before we even start, basically what we're doing is we're going to add time to this, and we're going to see how far away from the pier we're going to go. So originally, if we are at the pier, we are nowhere away as far as the distance, and no time has elapsed. So we're going to start at the origin, 0, 0. And it says it moves away from the pier at a constant rate for 5 minutes, and then it goes 300 meters away. So at the 5-minute marker, we are at 300 meters. So put a dot there. And so as best as you can, we're going to draw a line connecting these two. This will show the boat moving out to the water. I can't draw a straight line, but you guys can draw a straight line. All right, so that actually takes care of our very first sentence here. And then it drops anchor, which hopefully you know what that means. The boat's not going to move. It drops anchor there, and then it stays there for 10 minutes. So how far out should we go if we're going to do 10 minutes and they stay there for 10 minutes? We don't go to the 10-minute marker because that would only mean that that person was there for 5 minutes because we're already 5 minutes out. So if they're going to stay there for 10 minutes, that means we have to go up to the 15-minute marker and put a dot there. So we're at 15 minutes, and we're still 300 meters away because we haven't moved. So this is going to be a flat line going across. And then lastly, what are we doing? We're going to go back to the shore at a constant rate, but it's going to take 7 minutes to get there. So what time are we looking at here now? We're going to go from 15 minutes. We're going to add on 7, so that'll be about 22. So this here is 22.5 because every block is 2.5. So it's going to be right before that. So I'm just going to put it right here. And then we're going to connect those dots as well. Oh boy, this is tough for me. Nope. I'll retry one more time. It's a little better, maybe. Okay, we'll just pretend that works. So we did the first part, we graphed the situation. Second part, identify the points or the ordered pairs where the slope is changing. So I'm going to identify all the ordered pairs for all our points. So the very first one was at 0, 0. And then we went up and we changed slopes right here because it's no longer going up, it's going flat. That would be at 5, 300. And the next one would be 15, 300. And then the last one here, where we come back to the shore, since our distance is coming back to the shore, this is now at 0 on the y-axis here, but we are out 22 minutes, and now at 0. So we identified all the points where it changes slope. And you have to do that every time, because then we're going to use these points to make the equations. So hopefully you can figure out how many equations we're actually going to need if we have one slope here, one slope here, one here. So we're going to need 3 as well. All right, so we're going to use the endpoints of each line to write an equation. We're going to write an equation through the line for the 2 points. So we're going to use, let's use this first one here. It's going to be 0, 0, and 5, 300. We're going to use 0, 0, and 5, 300. So we should have how many different linear equations? I just talked about that. We should have 3 because there are 3 different slopes. It changes and has 3 different ones total. Write a linear equation for the first constant slope. So we're going to do the first one back here. Kind of highlight that. We're going to do that one there. And then we'll do the domain. I'll get to that in a second. So what we have to do, we have to take our point. Uh-oh. I changed that. Take our point 0, 0, and 5, 300. And we're going to do what we did in the previous video, which is find the slope first. M. And this is going to be labeled x1, y1, x2, y2. Do your slope. So it would be 300 minus 0. This is actually pretty easy. And 5 minus 0. So 300 divided by 5. So what would that be? Looks like our slope is 60. All right, after we have that, then we use our point slope theorem, point slope formula. Y minus y1 equals m times x minus x1. And plug in the numbers. So our x1 and y1 is really nice and easy. It's just 0. Y minus 0 equals our slope, which is 60, times x minus 0. This is kind of nice because if we distribute the 60, you end up getting 60x. 60 times 0 is just 0, so we don't have to write it. The left-hand side is the same thing. If you were to add 0, nothing would change. So it's just y equals 60x. So that is the first equation for this line. All right, so this one here is y equals 60x. The last thing we have to determine is the domain. So the thing is, it only is that line for a certain amount of time. So we're going to look at the x values for this line, and we're going to say that it is y equals 60x. That's the equation. But it's only that line from one point to another. So we're going to go from 0 minutes, right, up to when does it stop and change? And that would be 5 minutes. So I'm going to show you how to write that. Once you have the two numbers, we're going to go from small to big. You do 0 and 5. And the way you write this is you put less than or equal to signs on both of them. And in the middle is the variable x. Maybe I should change that a little bit. Less than or equal to. So this is saying you would graph this equation, but only for the numbers on the x values from 0 to 5. And that's when you would stop. So this is our first equation. And it gets paired with this domain from 0 to 5. Again, from 0 up to 5. And now we're changing. Now we're going to do an equation from here to here. Let's change it to blue. So we're going to go from here, this point, to this point, because it makes a whole different line. Write a linear equation for the second slope. So we need this point again, 5, 300, and we need this new one, 15, 300. 5, 300, 15, 300. And we're going to go through the exact same steps. Label the x1, y1, the whole thing. So we're really just doing the same thing multiple times. And we'll determine the domain for this one as well. So this one will be 300 minus 300 all over 15 minus 5. If you notice, the top becomes 0. The bottom is 10. 0 divided by 10, or divided by anything, is 0. So now our slope is 0. Now we're going to put it into that good old formula. y1 is 300, so it's y minus 300 equals our slope, which we know is from up there. So it's going to be 0 times x minus x1 is 5. So what happens here if we distribute the 0? 0 times x, that's gone. That's nothing. 0 times negative 5, that's also nothing. There's nothing on this side. It's y minus 300. The whole thing is now 0. Last thing to do, add the 300. Y equals 300. No x, nothing. That's your equation. Now what's that for? If we go back again, what domain would that be for? We're going to start that. If we go down and look at the domain, it's going to start at 5 minutes, and it's going to end at 15 minutes, because that's how long we stayed there and just sat. And the slope of 0 should make sense, right? Remember we said before, if we have a flat surface, flat line, that slope is 0. This is from 5 to 15. So our equation is y equals 300. That's only from 5 to 15. And then we fill this in with less than or equal to signs with an x in the middle. So that would be for the second equation. So we have one more to do. We're going to do this one here. Now it's going to change and slope downwards. So we should have a negative slope here. We're going from, again, 15,300 to 22,0. So notice when we do these, we're actually reusing some of the same points. We used 5,300 twice, and we're using 15,300 twice. But now it's being paired with a new number, 22,0. So 15,300 and 22,0. Write a linear equation for the third slope. 15,300, 22,0, and we'll do the same thing we've been doing multiple times before. Let's go through this one a little quickly. A little bit more quickly than before. y2 is 0. y1 is 300. Bottom will be 22 minus 15. So it's going to be negative 300 over 7, which is going to be disgusting, but that's okay. Looks like it's a 42.85. Alrighty, let's just round it up to 43. That'd be a little easier. Oh, negative. Okay, so now we have the slope. We can plug it into our equation. And then y minus y1, which is 300, equals your slope, negative 43 times x minus x1, which is 15. Distribute. Now we actually have something to distribute. Negative 43x. Oh boy. And then we have to multiply that together. 43 times 15. Looks like I got 645. Two negatives get multiplied together here, so it's going to be a plus. And then we have to add 300 to finish it. And that gets added on to the 645. So y equals negative 43, x plus 945. Should rewrite this a little bit. So that's the equation. Now if we go back again, we have to figure out from when to when, and that would be from 15 minutes. We go across the x-axis until the 22 minutes that we stopped at. So we would say it's this equation plus 945 from 15 to 22. Less than or equal to, x in the middle. So all these pieces, this equation and the last two we just did, get put together to make a piecewise function. So the last part says now combine all equations, all the ones we just did, to make the piecewise function. So what you do is we combine these by making a curly bracket, just one, and we're going to put all these together. So just go all three of them. We need y equals 60x from 0 to 5. And it just goes beside it on the same line. So that equation from 0 to 5, and then we went from 5 to 15. And that was, I believe, just 300. Y equals 300. That's back here. 5 to 15. And the last one we just did was negative 43x plus 945, I believe. And that's from 15 to 22. So that's the notation for doing the piecewise function. So you have three different equations, and it tells you exactly when to graph those equations. From 0 to 5, 5 to 15, 15 to 22. And so now we did one problem, a piecewise function. So the rest of the huddle asks you to do one more problem, but this one actually has, 1, 2, 3, 4, 5, 6. I wouldn't do all 6 of them, just maybe like do 2 or 3. You don't have to do them all. And then the same thing for the mastery. There's only 2 here. It's one straight one and then one that curls up. And so it asks some questions about that. And some fill in the blanks for that. I think that goes with this problem here. 1 and 2 kind of go together. But that's it for 3.2 day 2. 3.4 day 2. It's pretty short. It's also only one problem. But after this, we'll move on to 3.5.